Sergey is the co-founder of Chainlink, the leading decentralized Oracle network, working with leading banks, insurance companies, and large technology firms on the creation of universally connected smart contracts. Chainlink has become the de facto standard for Oracle use in the DeFi space, and most projects that are launching within Oracle immediately look to Chainlink to start. And Mark Miller is an early pioneer in the development of market-based secure distributed computing and smart contracts. He's an architect of the Xanadu hypertext publishing system, designer of the E and Dr. Seth's distributed secure programming languages, an ECMAScript committee member, a former Google research scientist, and a senior fellow at the Foresight Institute. So thank you both so much for joining us today. And to get us kicked off, I'm going to just start with a question about really what got you started on your journey. So you both exhibit an intense passion for security and distributed computing. It's an interest that is really underrepresented in general in our industry. And I'm curious how that passion came to be. And do you remember a specific moment? Please tell us your story.
Yeah, absolutely, sure. Glad to describe how I got into an interest in this. I think decentralized computation for me really showed a new and better model for how people can arrive at computations that they can rely on. And when I think about all the things that people are trying to do with computations, generally speaking, and specifically in automating certain contractual outcomes, I think that the decentralized guarantees that you get from both blockchains and Oracle networks and any environment where you apply decentralized computation with a lot of cryptographic primitives and a lot of guarantees around both how the cryptography is verified and the fact that that's verified by a large group of Sybil-resistant independent parties, either because there's a huge amount of parties or because you create Sybil resistance in some other form. I think that that's a new format for how people can rely on computing, basically. And once you have that new format where people can suddenly get greater and greater degrees of reliability, I think it opens up entirely new categories of transactions, entirely new categories of relationships between, someone on their phone having a private key and the computing system guaranteeing they're going to do something for them. And if people's access to computing systems through the internet and through desktops has, taken society to a certain point, then I think the ability to have highly reliable interactions with computing systems, because those computing systems can be relied upon, right? Because they're secure, because they're decentralized, because they work in a way that provides users certain guarantees, I think creates a new category of usage and relationships between people and computing systems, right? And so I genuinely think that the decision over the next few years for developers will be, do I build a web application or do I build a blockchain-based application? And I think if blockchain-based applications become easy to build and they maintain their security, then what you arrive at is a world where you probably do use a lot of web standards for the interfaces and for some other things that they're very, very good at. But the actual relationship to the computation or the digital agreement or the automation that the service is providing will happen in a blockchain-based way. And the systems that can enable that, I think, will form the backbone of how people relate to computation, generally speaking.
Yeah. For me, I always come back to a phrase of mine that I think is central to pretty much my entire professional life, everything I've done, which is, if we can lower the risk of cooperation, we can get a more cooperative world. For me, this started with my work with Ted Nelson on the Xanadu project, where we were conceiving of a distributed hypertext system well before the web. And we wanted to build a system that was uncorruptible, in which the Ministry of Truth revision of the past would not be possible, and which was uncensorable. So uncorruptible and uncensorable. Then later became a early cypherpunk. And throughout the entire time, the issue is not to avoid trust, but rather to recognize that trust is scarce, and that for however much trust that there is, you want to leverage it as much as possible. You want to achieve as much cooperation as possible at a given level of risk, and to be able to achieve a given, and for a given level of cooperation, to be able to achieve it at lower risk. By decreasing the risk needed for cooperation, we can get a lot more cooperation for the bounded trust that we've got, and repeated interactions within the framework of a secure computing system will lead to people dealing with each other in a more trustworthy fashion, because the framework rewards acting in a trustworthy fashion and punishes deceit. So that's sort of my general framework for this.
And Mark, I know that you've sort of addressed this problem in various forms through your career. I'm curious how you view the current implementation or existing systems that we've seen arise since the rise of Bitcoin with blockchains, but then also with oracles. How does that fit into the way you've thought about things over time?
Okay, so I initially was thinking, before the invention of blockchain, about the resilience of the system coming purely from diversity, loose coupling, competition, and reputation feedback. So you've got, like with the web, we've seen a loosely coupled decentralization where you've got lots of different sites. The sites never have to come to joint agreement on any one thing. Any one site might go bad, but there's no one site that everything depends on. So competition and reputation feedback keep the system as a whole resilient. The brilliant thing about blockchain is that we can build the equivalent of single institutions, single points on the network that are much more reliable than any of the components that go into creating it, and that can give us agreed answers. And this is much more robust than competition and reputation feedback, because, as I've heard Sergey point out in one of his talks, even when you've got institutions with a very long history and a very high reputation, in an emergency where people are panicking, that long history of operating with a high reputation is not a guarantor of reliable operation. So in an emergency where things really make a difference, that things are operating in a reliable manner, being able to have the rules of the system be expressed in code, be expressed in smart contracts, and running on reliable nodes, reliable virtual computers. A blockchain is a virtual computer that's built out of a massive multi-way agreement of many individual computers running in different institutions within different jurisdictions, cross-checking each other. By running things within that framework, you can understand ahead of time how things are going to operate in an emergency and get reliable operation both in and out of emergencies with a much lower cost, a much less ambiguity, and much more trustworthiness. So that's with regard to the internals of the computation, and that's what Agoric has been mostly focused on. And then what Chainlink has been focused on is, how do you get reliable, trustworthy information about the external world, which is just as important, because the computation is about things in the external world. That's why we care about the computation. And with regard to the external world, there's no source of objective truth, but you can, by again using the logic of massive multi-way corroboration of incentive structures, that reward trustworthy behavior and punish deceit, you can create information feeds from the external world that are credible. What the term that I love the term credible, because it's clear that that it's not getting at an absolute, but it's getting at something very, very important. And with blockchain and with Chainlink style oracles, we can build systems in which the computation is more credible and the information about the external world that is driving the decisions of the computation is more credible.
So Sergey, from your perspective, first off, I'd love to hear if that aligns with how you're thinking about things in general. And then, happy to go on to the next question, but would love to get your perspective on that.
Yeah, it does. I think credible is a great term. I think that's right. And I think there's this kind of not two sides to this problem, but there are two pieces to a lot of the smart contracts that people are excited about. And those two pieces are, you need an environment where you get guarantees about state and that the contract will operate once triggered. And then you need guarantees that it's going to be triggered correctly. And I think that this is the thing that me and Mark really, from the beginning, have felt very strongly about as being two equally important, necessary parts of the puzzle. Because if you don't have an environment where you can reliably trigger state, if you have credible data, that's not worth so much, right? Because the environment where things are getting triggered can get manipulated. And, even with credible data, even with highly reliable data sources being validated across multiple oracles, you still don't have what's needed to achieve the reliability that you want, right? And this is really the thing that blockchains have brought into existence, is an environment where you can now have these state changes in this format that never existed before, right? And state changes and contractual state are very similar, right? The technical ideas of state changes and contractual terms, it's just, what is the state of the computing function? What is the state of the contract? They're actually very, very similar concepts in certain ways. And then once you have state, people have been able to use that state for certain things, such as tokenization, signatures, things that are inherently built into blockchains. But the thing that has been missing, and the thing that we've kind of been working on, and I think me and Mark are both very excited to come into existence in a useful collaborative combined format, is the ability for credible reports, credible information, credible data to find its way into triggering state. And then you get not only state, but you get state that has a very valuable relationship with the outside world, which, when you look at the contracts that power ad networks, power global trade, power the financial system, all of those contracts relate to outside activities. They relate to people clicking something. They relate to goods being shipped. They relate to market prices. And these are all things people need to know. And I think that the collaboration between us and Mark, and us and Agoric, and us and systems that are able to successfully bring these two capabilities into a usable, adaptable format is something that's very powerful, because it opens up a new world of possibilities for what people can build in our industry. And I personally think that our industry will actually be redefined by this, right? Whereas our industry now is about, let's make tokens, let's vote on things in relation to our private key, or a token acting as a private key to vote, and let's do multi-sig, right? Like, those are the three categories of things blockchains are really used for today, predominantly. I think this new capability, this combination of credible data with highly reliable state changes put into a usable format for developers will generate a big shift in what people build, right? And I think you're starting to see this with DeFi, which is a lot of what this hackathon is about. You're starting to see people build applications that are not just about make a token, make a DAO, sign something with a multi-sig, but they're about using the capabilities of blockchains and using the capabilities of credible data from oracles to generate value beyond the creation of a token and into the realm of, we have a contractual relationship. That contractual relationship might hold the token for us, but it's really the contractual relationship that blockchains and smart contracts are now able to embody and make uniquely capable and useful for people.
Yeah, and there's a further credibility issue that I think has been neglected by the blockchain space in general, and in fact, that I think that the existing DeFi that's been happening so far has been neglecting quite terribly, which is the credibility of what the code means. Code understanding is understood to be hard. Contracts need to be understood in an adversarial context. The contract is drafted by one party. One party might have an interest in having the counterparty misunderstand what the contract is. Contracts and code have tremendously less ambiguity in many important ways compared to natural language contracts adjudicated by lawyers and courts. But it's still the case that code is very, very hard often to understand how reliable it is. So one of the things about our architecture, which you'll all be experiencing in the hackathon, is it's an architecture for partitioning risk so that different aspects of the risk are at risk to different pieces of code. So in particular, Dean mentioned in his first talk, Zoe providing offer safety. Offer safety means that there's this first element of risk of any contract of the quid pro quo, is I'm offering this in exchange for wanting that in exchange. And then Zoe provides a fixed amount of code that guarantees offer safety is satisfied independent of how the contract might misbehave. And then our contracts are organized into highly reusable vetted components that can be composed with other components such that most of the residual risk, the risk that remains after offer safety is taken care of, can be moved into highly reusable components, contract components. So the key thing there is that we're always going to be writing new contracts, we're always going to be creating new code, but to the degree to which we can not just be reusing highly vetted, understood components, but doing it in architectures that can be moving most of the risk of concern into those components, so that the compositional code that is newer and less vetted is also the one that has less residual risk. We raise the credibility of the system as a whole with regard to the risk that you're agreeing to a contract that you misunderstood.
Yeah, that's absolutely right, and I think that's a great point, and I think we're starting to see this happening in DeFi, and systems that can make that happen even more are going to be very powerful, because you actually see two very important dynamics in the contract world. What you see is people copying agreements. You see, like, the second any bank or somebody makes a new derivative or a new financial product or something, if it's very contract based, the other banks just copy them. Law firms really shift around a lot of different templates of contracts that are all kind of the same thing. And they just have, and you almost get a inherent industry standard template because people don't want to reinvent. There's an entire category of people that all they do is they make up these contracts, but then they don't even edit them as lawyers, right? They just make the contract. And then other people copy that, and that brings a new type of agreement or a new type of thing into existence. So I think the first really powerful thing is that these little pieces of automation that are hyper secure are open source, and they're going to have a lot of eyes on them. And so in the implementations that we've built with insurance companies, banks, and a number of other people, we've always opted for this separation of concerns in a service-oriented architecture, where we wanted to make each contract its own little service, on-chain service, that interacted in limited ways with the other services, right? And this separated your concerns about each individual piece. And then even back then, we would, and even sometimes now when we talk to people, I still feel very strongly that what you're going to have on an industry by industry basis is, like, just like you have the ERC-20 standard for tokenization, you're going to have a standard that's going to emerge for doing bond payment calculation, for doing insurance payouts, for doing evaluation of certain types of events or certain pieces of financial transactions. And I think that what DeFi and the DeFi protocols out there right now are actually doing is they're starting down this path. And some of them are farther and some of them are at the beginning or in the middle. But they're just like you have the ERC20 standard, because it's open source and because everybody can get around it and become comfortable with its security and reliability, and it's completely fine to copy it, it's completely open source, you're going to see a lot of smart contracts that become the way that a certain financial product, not how it works in whole, but how a portion of it works. And then if you want to make a slightly different financial product, you can take the 3 parts from the first one, add 2 more parts, and get the benefit of the security and all the thought that people put into something like a bond payment calculation service, right? And so that's a very powerful, very, very powerful dynamic. And I think the environment that has all of those building blocks and all of those building blocks in a secure, reviewed, and very composable way has another advantage, right? It has the advantage of people having an environment where they can once again compose those building blocks. And then the other huge kind of thing that, I hope we can enable is that of those services, a lot of them will be on-chain data, a lot of them will be randomness, a lot of them will be resources from oracles that aren't about some kind of code that can do something on its own without an input. So I think the combination of these building blocks mimics what you see in the web world as far as libraries and APIs. Really, it mimics as far as what you see as far as libraries. And I think what oracles do is they mimic what you see with APIs. And just like in the web world, libraries and APIs being combined in very productive ways, I think that's the stage of our industry's evolution that we're now embarking on.
So just to jump in quickly, there's been a discussion coming up in chat around how much computation should live on chain and how much should live off, and how do you guys view that? And open to either one of you taking it first, obviously.
I'll take that. One of the things that was very puzzling to me when I first saw blockchain is I've been thinking, working on smart contracts, as have many of the people at Agoric, for decades before the invention of blockchain. So all of our contracts were thought of as things that were not on chain. The great invention of blockchain, as I mentioned, is that it's a credible computer, but in particular, a public permissionless blockchain is a computer, a place to run credible code that is immediately credible to everyone in the world and able to be open entry without prior arrangement. So for contracts which are like public institutions that need to be open entry to anyone in the world, public blockchains are absolutely the central place that those things should be put. Many, many contracts are much more local than that. Many contracts are things that are individually negotiated between a small set of parties that run for a while and shut down, and for which those parties might be more interested in not revealing the state of those contracts to the world at large than they are in the credibility necessary to have arbitrary other parties playing the contract when they're not interested in inviting everybody else in the world to play in those contracts anyway. So I think most contracts are small and local. Some contracts are very importantly need the worldwide credibility. So I think we're going to get a tremendous mixture. So so it's very important that our technology work both across public blockchains, private blockchains, non-blockchains, and that it operate in a distributed manner so that contracts running on any one of those platforms can talk to contracts running on any of those other platforms. I like to make the comparison again with the web. The web is primarily a public phenomenon. Most websites, when we think of the web, are the public websites that everyone can get at from anywhere in the world. But it's also very important that companies have their own internal private websites behind the firewall. And what's especially important is the seamless integration, that somebody behind a firewall within a company clicking on a link on an internal web page can follow that link into a document on a public web page with no friction at all. I think the same kind of mixture of public and private and proprietary and all of these arrangements will happen as well. We need a seamless, frictionless distributed computing system so these things can interact across all of these boundaries.
I mean, yeah. As I understand the question, it was around, and I think that all adds up, and it makes sense, and that frictionless kind of experience with reliability and security built in is going to be the real innovation of our industry, right? And I think the frictionless nature of it simply hasn't appeared yet, but there's a lot of smart people working towards that end, us included, right? And that's really what, once you reach that point, then it's an obvious thing, right? But before that point, it's not. But it to us, it's quite obvious that once you have security and reliability and it becomes frictionless, obviously everyone prefers that. In terms of the question of what amount of computation lives where in these various environments, public or private or oracles versus layer ones and all this type of stuff, I think what you really need is a system that allows various use cases to have flexibility. So what you don't want to do is you don't want to make a rigid system that forces people to do things in ways that they don't necessarily want to. So if you have a system that provides certain guarantees efficiently, that's a very good starting point, right? So if you have certain state changes at certain scale, at certain levels of usability, and then I think the question from there kind of becomes, what amount of privacy or scalability or additional computation do people want to do in layer ones against their efficiency dynamics? And what amount do they want to do against an environment that's separate and different that perhaps provides privacy, or perhaps is able to do a computation around data in ways that you can only do if the data remains private, because there's a lot of data out there that has to remain private, but we still want it to be usable by a smart contract. So I think what this comes down to is an evolving world where there are certain things blockchains are very good at, and there are certain things oracles are very good at. And then both of those worlds become more and more flexible, and I think they should become more flexible. And then developers make a choice based on their privacy requirements, efficiency requirements, how much data they want to put into a chain, all these types of things. And in that world, if chains become hyper efficient and super private, right, then you probably have a lot of computation going in there. And in environments where chains become not hyper efficient, but they just become efficient, and they don't reach the same levels of privacy, or they can't reach that for some reason because you're inherently putting data into a layer one environment, even though it's encrypted or something, right? But there's all kinds of really clever tricks with cryptography. That's like part of what it's about. You arrive at a place then where you probably have layer ones doing certain mission critical computations that you want transparency for, but for which, maybe there are still some efficiency concerns at global scale, and maybe there's some privacy concerns. And then you can get privacy from oracles with zero knowledge proofs, or you can get some additional scalability boosts by putting a portion of the computation in an oracle that you didn't want to put into a layer one. But really, I'm comfortable with either direction. It just depends on the degree to which layer one systems can solve those privacy and scalability concerns. And I think they will solve it to a certain degree. But then there's another question of what is the global requirement for that, right? Like what is the global requirement for a global derivatives blockchain that settles trillions of dollars at millisecond or second speeds, right? Like how does that look? And so I think there's still some chapters to be written here, but for the next few years, I think there's going to be a very positive collaborative overlap where oracles can enable a lot of functionality that blockchains don't have yet in terms of scalability or privacy. And what that'll actually let people do is that'll let people build much more important use cases on blockchains using the transparency and secure state change capabilities they do have. And at the end of the day, everybody benefits because more wonderful use cases go live until blockchains are able to do that privacy or scalability in a certain way. So I think privacy is probably the place where people will find some decisions to be made about what they want to put on chain versus what they want composed into a smaller subset of oracles.
Great. Well, thank you guys. And so I know we're at time. I mean, I have one quick question that I'd love to slip in, if possible, and maybe to Sergey, if you don't mind. Given that you at Chainlink, you've dealt with a bunch of enterprises, organizations outside of our space, would love to know what you think is going to be required to take blockchain and take our space mainstream, and what do they see, or what are they looking for as you talk to them?
I think it's I think there's actually kind of two paths. One path is the slower path, where our ecosystem slowly grows with the value proposition it has. And I think the usability of the smart contract system you use is going to be very important for that. I think the ability to get security from it, I think all these composable pieces being put together on it. And I think we're going to have better and better products built for our own ecosystem. And our own ecosystem is sufficiently large that people doing that can be successful, that they can have a successful enterprise, they can get financing, they can be considered successful in the technology landscape. And that actually creates a virtuous cycle of more people doing it, more products for the crypto community, the crypto landscape having more value to more users. And that kind of just keeps that cycle going, because success kind of breeds more success in that sense. I think the second larger possible win is that if people see the issues with existing systems through something like a global financial crisis of some kind, which, you know, those happen on an 8 to 12 year cycle, and we're at 12 years. So it's very possible that there's some kind of financial issue that blockchains uniquely solve. And once that financial kind of markets issue becomes clearer to people, I think there will be a wholesale move towards blockchains and decentralized systems and guaranteed smart contract-based systems. I think in that world, people are going to look at platforms, you know, like Agoric and platforms that they can easily interact with using their existing models. And that's going to be important for them to adopt this technology. And they're at the same time going to look at, how can I acquire valuable, useful data, and how can I connect the platform that I'm developing a smart contract on, both to my existing enterprise backend and into various data, right? So I think what will happen to your earlier question is, everybody's going to build in different kind of ways. I think that there's going to be a number of people that build in more privacy focused ways, and there's going to be people that build in more public blockchain. Let's put a lot more logic on the blockchain, even if it's more costly for whatever reason. At least that's the dynamic I see now. But once again, it's a difficult dynamic to predict, because the scalability gains are just coming into existence. The privacy preservation capabilities are just coming into existence. And I think the blockchain space at this point is just about ready for a big influx of demand for enterprises and Web 2.0 companies, because they can finally build in a way where they acquire a dynamic with code that they're used to. They acquire a way to build things either using existing languages or existing design patterns, and they're also able to connect their existing system through something like an Oracle or a Chainlink to command contracts, and also able to get data into those contracts, right? And so it's actually quite fascinating, because in my opinion, the slow case means we are winning slowly, which is great, because the ecosystem is big enough. And the large case, where people suddenly have demand for these guarantees on an enterprise level, because the global financial system and the sensitivity that creates for users leads to that demand for them for this technology, will evolve into all of these kind of new building blocks, right? And what percentage of those building blocks get these standards is actually quite a fascinating question. But I think that's where we are in the next year or 2 years, is that both the crypto landscape grows and makes a lot of great building blocks, and the enterprise world, in my opinion, at some point soon, we'll probably rapidly see the value in this, because their users will ask them, how can you guarantee to me that my relationship with you is in a certain state, rather than just saying it is.
Great. Well, again, we're 6 minutes over. I'd love to keep this conversation running for another hour or so, but I want to be respectful of both of your time. I really appreciate both of you joining. To those of you who have joined for this talk and are still potentially interested in joining the hackathon, please go to hacktheorb.com and join us. We've got Chainlink folks helping, Agoric folks helping, and we'll get you set up on your systems. Again, Sergey and Mark, it's been a real pleasure, and we're excited to keep the conversation going, and maybe we can start this back up again at some point in the future.
Yeah, my pleasure. Always great to see you, and excited that we're doing the hackathon together. Great to see you again, Mark. Roland, thank you very much. Have a great hackathon, everyone.
Thanks,
yes.